Hi, my name is Leonardo Flores. Please call me Leo, and I'll be giving my talk on cyborg authors and the Eliza Effect. Let's begin with thinking about the concept of the cyborg. As Donna Haraway defines the cyborg, a cyborg is a cybernetic organism, a hybrid of machine and organism, a creature of social reality as well as a creature of fiction. What I like about this definition is that it goes beyond the sort of Robocop prosthetic Borg kind of literal human machine fusion, and it really uh, gets into the sort of mental and social ways in which we have become blended with machines. The idea of cyborg writing is that we are already cyborg writers. We've been using word processing software, spell and grammar checkers, autocomplete, predictive keyboards and text, computational writing at least since 1953, natural language generation, and now AI systems trained on large language models. So, this is an old story, an old practice, and we're going to look at some of this history today. The origins of the genre, and I'm going to focus on two genres, generative writing and bots, um, is starts with love letters. In 1953, Christopher Strachey, depicted up above working on the Manchester Mark I computer at Manchester University. He programmed the love letter generator, and it was titled Love Letters. And this is the first example of computational literature, of electronic literature, as far as we know. And I'm going to use those terms are all fairly interchangeable. Some are more specific than others. I'm going to use the more neutral term generative writing to talk about these kinds of practices of writing using computer generation. And I'm using the term writing to separate it from literature, uh, which is a specific kind of artistic writing. The other example is Eliza, uh, programmed by Joseph Weizenbaum in 1964. This is a chatbot, also been known as a conversational agent. I'm going to use the more general term bot to refer to it, but we'll see how that developed. Now, love letters, and you can see the Ferranti or Manchester Mark I computer uh, depicted there, would generate when operated. This was programmed on punch cards. Would generate these these texts, these little love letters. Let's take a read at one of its outputs. Dear Moppet, my affectionate desire curiously yearns for your adoration. You are my fervent sympathy, my precious love. My amorous fancy treasures your amorous fondness. You are my curious tenderness. My affectionate affection affectionately cherishes your enthusiasm. My charm adores your affectionate heart. You are my dear thirst. My yearning seductively wants your sympathy. My devoted fondness hopes for your liking. Yours eagerly, MUC, which stood for Manchester University Computer. Now, you can tell that a human being probably did not write this. I think when you get certain words being overused, like affectionate, affection, affectionately, that's probably generated output. People would probably stop themselves from going so far. But I think one of the interesting things is that this is the possibility. This text was possible, perhaps, I mean, and intended, but may have surprised the reader, the author, in terms of its output. And it leads to things that we might not have imagined. So when a writer creates a little machine, it produces a cone of possible texts that it can produce, and therefore, that gets modified and developed. The example that I have here is from Nick Monfort's Memory Slam 2.0 re-implementation. And let's take a look at the source code for this re-implementation. If you see on the image on the left, uh, we can see that we have variables and data sets. We have first and second, darling, dear, honey, jewel, second, duck, love, moppet, or sweetheart. We have adjectives, nouns, adverbs, and verbs. And on the right, you can see a little bit how the grammar, how these words and these variables are selected and activated and assembled. And there's these functions that determine how long the letter will be and things like that. So again, this is a little software machine that generates output that is intended by an author. Now, there are different generative writing techniques. The one you have just seen is the generative grammar, right? The program writer programs a little generative engine. They modify it until they're satisfied with the output, and the resulting work has their intent, but also goes that extends that intent beyond their own control. So they are yielding some space, some agency, if you will, to the computer's process. Another technique commonly used is algorithmic transformation. A writer programs a script that will transform a text, a pre-existing text. They modify the script until satisfied with the output, and the result is intended. And there are probabilistic models. We'll see an example of an early Markov chain generator. And then we have, of course, large language models, which are, right now the source of much concern and play and creativity. And writers can customize, train, and prompt these engines to different extents. So, an example of an algorithmic transformation is Hugo VK's 50,000 Meows, which he created for NanoGenmo in 2014. There, he basically can take any text corpus, let's say Moby Dick, and transform it into meows. And not just into meows, meows that are the same length as the words. So you can read that yourselves and enjoy that. Another example is Liza Daly's A Physical Book, which again takes a text and applies these kind of visual transformations. And so it's also a neat way of not actually changing the text's uh, words, but the presentation of them. Now, an example of the probabilistic models, back in 1984, Hugh Kenner and Joseph O'Rourke uh, published in Byte magazine a travesty generator for micros. And this travesty generator, basically, it's a Markov chain generator. It creates, you feed it text, and it creates basically a small language model, a probabilistic model, and based on the rules that it has created, that probabilistic model, it will generate texts using that corpus of texts and the probabilities of one word or letter or sequence of characters might follow another. And so this is a really interesting tool to actually, it mimics voice and style. It's not very good at keeping logical coherence. So it's not a semantic model, it's a probabilistic model. An example of a work published using a tool like that is The Policeman's Beard is Half Constructed. Notice that it is attributed to Racter. So they say computer prose and poetry by Racter. But of course, William Chamberlain worked with a computer program called Racter to develop the output, generate the output, and then select the output that ultimately ended in the book. So to attribute it to the computer is more of a publicity stunt, I think, than the reality of, this is a cyborg practice. This isn't just Racter, it's William Chamberlain working with Racter. And there's a little example of some of its output text. Now, GPT or generative pre-trained transformers are what we know as ChatGPT and large language models. They're trained on large data sets. They have semantic information. They're fine tuned. They can be trained on specific corpora, and they can be programmed, prompted. And a really great example is Lillian Yvonne Bertram's A Black Story, in which they ask GPT-3 to tell me a black story. That's the prompt. And the story that ChatGPT, the just plain vanilla ChatGPT generates, is this sort of sad story of racial strife and black pain. And the contrast is huge when, again, Bertram trained that GPT-3 with the work of Gwendolyn Brooks. And notice that the name here is G. Gwendolyn PT3 Brooks. And when prompted to tell a black story, it produces a story that carries the voice of Gwendolyn Brooks. It is nurturing. It is about books and reading and the love of reading and the love of the community. And it just transforms it. So it is a wonderful interrogation of these technologies and how they're trained. Now, bots have different characteristics and strategies. They use a lot of the same kind of practices as generative works, but they operate autonomously and they can generate or deploy even text, images, and other output. They frequently have interactivity, and an important strategy they use is characterization. They are these active, real characters that have programmed behaviors. In print writing, you can only tell what characters have done. Here, you can have a living character, or living in quotation marks. So Eliza was developed by Joseph Weizenbaum at MIT from 1964 to 1967. The chatbot used a script called Doctor, which made it act like a Rogerian psychologist, constantly focusing attention on the person that it interacts with. And Eliza was named after Eliza Doolittle in Shaw's play Pygmalion. Here's an example of some of the output. I'm not going to read it, but you can notice that it makes reference to some of the key terms that the person uses. So, my boyfriend made me come here. Is it important to you that your boyfriend made you come here? And so it creates the illusion that it's actually reading what the other person is saying. This evolution of chatbots after Eliza, we have Parry, which simulated a paranoid schizophrenic. Again, notice the characterization. We have Siris and Alexas and Google Assistants and Cortanas. And of course, now we have AI chatbots that are quite sophisticated. Now, Sherry Turkle defined the Eliza effect as follows. Computers make it increasingly tempting to project our feelings onto objects and to treat things as though they were people, an impulse I called the Eliza effect after the early AI program that was designed to seem like a solicitous psychotherapist. And Noah Wardrop Fruin elaborates on this and adds what he coined as the tailspin effect, based on a game, a generation game. Just as the Eliza effect is used to describe systems that give the audience the impression of a much more complex process than is actually present, this tailspin effect may be used to describe the obscuring of a complex process so that it cannot be perceived by the audience. And so, between the projection that we bring to some of these machines and the obscuring, I think we reach a kind of a bind. So, how does this affect our understanding of AI? Well, the Eliza effect, right? Characterization is a kind of social hack. When you have a gendered bot, you're going to respond to it in certain ways, and this is something that has been studied. AI is a kind of personification, the very notion of intelligence. And LLMs evoke that sense of generalized AI or generalized artificial intelligence, which is actually these machines thinking in the way we do, let's say. The tailspin effect, these LLMs are black box systems, and their natural language interfaces obscure computational processes. And the problems arise when people project onto AI hopes, fears, you know, prejudices, etc. They tend to give it too much agency. And the nice thing about cyborg writing or understanding cyborg writing is that it subverts some of these effects. Donna Haraway, a return to Haraway, where she says that writing is preeminently the technology of cyborgs, etched surfaces of the late 20th century. Cyborg politics are the struggle for language and the struggle against perfect communication, against the one code that translates all meaning perfectly, the central dogma of phallogocentrism. That is why cyborg politics insist on noise and advocate pollution, rejoicing in the illegitimate fusions of animal and machine. And I love this illegitimate fusions of animal and machine. I think when people use any AI system these days, especially students, it feels like this almost transgressive act. And so when we conclude with the idea of cyborg authorship, I reiterate we're already cyborg writers. We have been doing this for a while. But cyborg authorship, you know, carries intent, even if it's generative writing. That authorship brings a certain responsibility and ethics for the text that is put out there. And readers need to read beyond the text to understand process, including computational processes. And electronic literature shows the way. There have been over 70 years of cyborg writing, of computational writing, of electronic literature. Electronic literature has developed things like theories like software studies, critical code studies, these methodologies to really kind of go deeper into the supporting structures that make this possible. And there is a massive corpus of creative and critical writing that I think is worth exploring because we have been grappling with these questions for a very long time. Thank you.